So, hi, hello everyone. A big hi to all the warriors in the classroom. बच्चा लोग कैसे हैं सब? Everyone. I know that I'm meeting every one of you after a very long time because of the 12th standard examinations, isn't it? And I was also not feeling well enough. So here I am, obviously, to make this particular various group so amazing and to learn the topics of class 11 in a super great way. Let me say hi to everyone here in the classroom after a very long time, right? I'm so excited. I'm so happy also. So, hi Kamlesh, Preeti, Sabra, Shreya, Krishna, then Miara. Okay. Then who all we have? Everyone. Everyone, show me your energy and tell me how much excited you all are to learn the mechanical properties of fluids after a very long time. Everyone, go for it. Kamlesh, good evening. Good evening. Very nice, Shreya. Okay, good to know that. Good to know that. So, bacha log, in today's session, okay, we'll be having 2 or 3 more sessions. Within that, we are going to wind up this very long chapter of mechanical properties of fluids. Okay, and in today's session, the main topic of our discussion will be viscosity, viscous force, okay, and the terminal velocity. These topics, Hana, will be going in deep, understand all the concept. We are going to do so many amazing problems, and after the session, this particular topic is going to be super clear to every bacha logs here in the classroom. Fine. So, whoever is seeing me for the very first time, this is Ameer, your physics educator at Unacademy, and a bit of introduction about myself. Can you all see it on the screen? I have an experience of more than 3.5 years in the field of teaching JEE, NEET, and board student. I am a beta graduate from NIT Calicut in mechanical engineering, and this is all about me. Okay, chalo. Now, let us have a look at the schedule for this particular week. This entire week we are completely packed, mera bacha log. Okay, you can see what all we are going to do to make this particular chapter of mechanical properties of fluids so concrete to every one of you. So today on 13th we'll be having the 4th session. Tomorrow the 5th session, and so you'll be having the last 7th session on Wednesday, which is 15th of December. Then on 16th, we'll be having the NCERT examples exercises we'll be discussing, and on 17th, we are having the final mega Menti quiz on this particular chapter, where we'll be discussing all the important questions of this. Most important multiple choice questions will be discussed, right? So don't miss it. This week, we are going to complete this particular topic with by doing so many problems here. Okay, good. Now, bachalo, can I ask a small favor from every one of you? Can you all share the class, Anna? Can you share this particular class to all your friends and ask them to join as soon as possible? Jaldi se everyone. Jaldi se. Okay. So Jashan, Shraddha, Sabra, Krishna, to every one of you. So jaldi se jaldi share the class and ask your friends to join. So bachalo, if you don't want to miss the live classes from any of your favorite teachers, be a part of this Telegram channel. The link is given here and also in the description box. Jaldi se join kar le bachalo. Okay. Bugs Bounty, those who don't know, it's an amazing program which can help you to get so many prizes. You just go to the description, there you'll find a form. Fill the form if you're finding any inappropriate content in the videos uploaded by Unacademy. If it is valid, है ना, बहुत सारा prizes मिल जाएगा आप सब लोगों को. Then, I don't think there is anyone here, but chalo, who haven't written the Unacademy Combat scholarship test. Is there anyone? Those who haven't, jaldi se jaldi enroll kar le. It's an amazing method, right? You can grab so many prizes because you just listen to, like, just have a look at the amazing profits or benefits you are going to get after writing the scholarship test. Okay. First of all, it is completely free registration. If you want to enroll for this Unacademy Combat scholarship test, just you have to remember this code. The code is AMB10. So use this code, enroll for Unacademy scholarship test. And once you get a first 3 rank, if you are one of the top 3 rankers, what will you get? Medals will be given. And for the first top 25 rankers, certificate is also given. And one more thing, for the first top 3 rankers, 1 year of plus subscription. And not just the first 3 rankers, others are also given scholarship. You all can see that. So what, okay, or what is actually resisting you from enrolling to this Unacademy Compact Scholarship Test? Everyone, jaldi se aa jaiye and enroll for this. The code is AMB10. It happens on every Sunday at 1 p.m. Rank 1 gold medal, rank 2 silver medal, rank 3 bronze medal. Wow. Easy way to grab some medals. So jaldi se everyone. Now, I think you all have share the classroom to all your friends and ask them to join. In the meanwhile, right? I'll be just be explaining to whoever is new to this Unacademy platform, right? I'll be just explaining about this Unacademy Plus subscription. Everyone, just listen. Now, nowadays everything is available in YouTube. I totally agree to that, and many of us are studying through YouTube. I do appreciate this. It's an amazing thing. But some of you need some personal guidance and personal mentoring directly from the teachers. For those people, the Unacademy Plus subscription, this is the right place. And other than that, for some of you, don't you all want to get clear your doubts at the moment when teacher is taking the classroom? This can also happen once you are a part of Unacademy Plus subscription, because there is a special feature which we call it as in-class call feature. So whenever teacher is taking a class, you can call the teacher through the app itself. So he'll be taking the call and will be explaining all the doubts to you through your voice. So you can ask the doubt, okay, and at the moment itself, your teacher will be clearing your doubt. I think this is an amazing, awesome feature, I think, right? So learning something without doubt, isn't that the dream of all the students? This can happen once you're a part of Unacademy Plus subscription. More than that, top educators of the country who's having a very good experience will be there to teach you mere bacha log. They'll be telling you what to study, what not to study, how to study, what all multiple choice questions you should be practicing. Okay, everything these teacher will be telling you. You just want to follow them. You're going to ace in all the competitive examinations you are preparing for, and finally ending up in the colleges you are dreaming about. Then study materials will be given, practice test, live test series. All these things will make you super confident and will bring the best from every one of you, bacha log. If you go for 6 month subscription, it will cost you 1667 per month. And if you can remember this code, which is AMB10, instead of paying 1667, you only have to pay 1500 per month. So don't you think it's an amazing feature, right? It's an amazing referral code. That is the magical referral code, which is for the entire physics family. So by heart this and use this referral code once you make the subscription. Okay, don't forget it's AMB10. Now, bacha log, if we proceed further, we have the iconic subscription. Here we'll get all the features of plus some extra features such as personal mentor. Matlab, a person will be assigned to you. He'll be telling you how to study, what not to study, for everything related to your academic activities. 24/7 this person will be there. So you'll feel so relaxed, you'll feel so calm. So you can learn in a much chill manner when this person is there. So this is an amazing feature of iconic subscription, I say. Then live doubt solving classes specially for you. Weekly reports will be given to you. So for all these things, if you're going for a 6 month subscription, it will cost you 2833 per month. And if you can remember this code kya hai? AMB10. Don't forget hamara code AMB10. So use this code and you just get it for 2550 rupees. Wow. 10% discount directly just by remembering these code of AMB10 and maximum offers while you make the subscription. Okay. And there is one more reason, bacha log. So you all know that the term 2 syllabus has to be started now. We also have started in our batch, which is the Spark batch. So we just started with the chapters, right? So jaldi join kar le. It's a 2.5 months course where we'll be covering all the topics from all the subject, as you can see. So jaldi se join kar le, and you all know the code you have to use for enrolling AMB10. So we'll be giving you special guidance, special mentoring. In the class itself, doubt clearance, everything will be there. So you'll love it and you'll be learning the entire term 2 in an amazing way. So make sure that you're a part of it. Okay, everyone. So hi Mahi, hi Shraddha, hi Shreya, Rashan. So tell me, are you all ready for the session to get started? Miara is, yes, let's get started. Then Mahi, hi. Preeti, oh my goodness. Preeti is with full of energy, with full of fire symbol. Jyoti, Shreya, Nancy, Arpan, Lucky, Nidhi, Ameer sir ki fan. Let's start. Okay. So fans are here. All my amazing bacha logs are here. So why not? Let's get started. Here we go. Bacha log? Yes. So tell me, in the last class where we talking about the liquid which is flowing, tell me yes or no. Yes, we were talking about. And did we talk about the Bernoulli's principle or the Bernoullis equation? Yes. Tell me what this Bernoullis equation is actually talking about. It is actually an energy conservation, है ना? It is actually talking about the conservation of energy, right, per unit volume. Nothing else it is discussing about, right? For a liquid which is flowing, total energy per unit volume is always a constant. That is simply said in Bernoullis equation. So you don't have to get scared once you listen to the word of Bernoullis equation. Okay, now let us go for the equation. We all have learned this particular, right? Okay, tell me. So here we have a simple tube through which the water is flowing. Okay, the water is flowing just like this. Can you all see the tube? Can you all see the tube? Yes, you all can. Let's say the pressure at this particular end is P1. It is at a height of H1 and the water is moving with a velocity of V1, let's say. Okay, and at the other end of the tube, pressure is P2. It is moving with a velocity of V2 and let's say it is at a height of H2. If we apply the Bernoullis principle, what does it say? P1 plus half rho is the density V1 square plus rho g H1 is equal to P2 pressure at the second end plus half rho V2 square plus rho g H2. Isn't it? मतलब ये है कि the total energy per unit volume is always going to be a constant. मतलब P plus half rho V square plus rho GH, this always will be remaining as a constant. This is what is being explained in Bernoullis principle or Bernoullis equation. We already have explained this, right? Okay. Based on this, did we explain about Venturi meter? Right? A meter which will help in finding out the velocity with which a liquid flows through a tube? Yes. Fine? Okay. Now what we are going to do? Now we are going to discuss about some more applications of Bernoullis principle. Okay, so the reason why I have left these two applications of Bernoullis principle to be discussed in this classroom is like, so that before we start with our viscosity and viscous force, you will be getting a bit of introduction, right? You will be getting a bit of revision about this Bernoullis principle again, because this is very important topic. That's the reason. Fine. Okay. Now, an application of Bernoullis principle, which we haven't discussed in yesterday's class, I'll be discussing thoroughly. So everybody write the heading. Applications of Bernoullis principle, second one, speed of efflux. Everyone here in the classroom, write the heading, speed of efflux. Don't worry, I'll explain everything. Okay. Okay, it's super duper important, right? Richa, Niti, Miara, Shreya. Okay. Now, what is this efflux? I'll tell you. Can you all see a beaker, right? Or a tube or anything, right? Okay. Now, it has some water inside. Tell me what happens once you make a small hole at the midpoint of this particular tube? What happens? Yes, the water will start flowing out. This water, which is flowing out through small nozzles or small holes made in the beaker, we call it as efflux. This is what we call it as efflux. The water coming out through small holes. Now, by using the Bernoullis principle, what we are going to do? We are going to find out the speed with which it is coming out. By using the Bernoullis principle, we are going to find out what is the speed with which the water is going to flow out through these small nozzles, which we call it as efflux. Okay. Now, I'm going to write down the formula directly, then we'll be doing the derivation. Let's say this particular nozzle is made at a height of h from the surface of the liquid. The velocity with which the liquid will be flowing out through this particular nozzle is given by, everybody write down the formula. This is root of 2, okay, g h. H is the height or the depth of this particular hole from the surface of the liquid. So the velocity with which it will be coming out is root of 2 into g into h. Let me ask you, before I proceed further, let me ask to all the bacha logs here in the classroom. Bacha log, right? Do you remember this particular equation from anywhere? Okay, tell me, can you recognize this particular formula for the speed of efflux as root 2 gh? Yes, Nidhi, very good. Shraddha, yes, very good, very good. Don't worry, I'll be explaining or we'll be deriving this formula. But before that, Proof. I'm going to explain the proof. But before that, tell me, have you seen this particular formula ever before? No, 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 no. I'll just tell you. But chalo, don't worry about the explanation. Don't worry about the derivation. We are going to derive it obviously. Surface of the ground. Okay. Let's say we have a body which initially we are holding. Matlab initial velocity is 0. From a height of h, if you are going to drop this body, once it is about to reach the ground, what is the velocity? What is the velocity just before it hits the ground? Formula क्या है? It is root of 2gh. So now you don't have to remember this or by heart this particular formula differently. It is the same formula. Matlab once you drop a body from some height of h, the velocity with which it hits the ground is root 2gh. So the same is the formula for the speed of flux also, root 2gh. Velocity of drop body. Very good, very good. So now everybody do remember. Great. Okay, great, great. है ना? Now, proof चाहिए. For every one of you needs a proof, isn't it? Let's do the proof. Let me explain it. How the formula is root of 2gh. So everyone take a beaker. सबने ले लिया? Beaker ले लिया? सबने. Okay. Take some fluid inside. Done. Okay. Now I'm going to make a small hole here, okay, which is at a height of h from the surface. So what happens? Yes, the water will be coming out. Now consider this as the first point and this is the second point. Fine. Okay. Now let us start marking everything. Surface of the fluid, let's say it is at a height of h1. The hole is made at a height of h2. The pressure here, tell me what is the pressure at the point 1? At the surface of the liquid pressure कितना होता है? Array on top of it there is only atmospheric pressure. What about the second case? At this hole what is the pressure? Array pressure at the point 2 is also atmospheric pressure. Why? Because this point is open to the atmosphere. So at the second point also the pressure is P atmosphere. No doubt in that. Fine. Okay. Now let me mark the area over which the entire surface of the liquid is A1 here. Let's say the area through which liquid is coming is A2. Done. If you know this much, now what is left? Applying the Bernoullis principle. Start applying. P1 plus half rho V1 square. V1 is the velocity with which the water comes out here and V2 is the velocity with which the water is coming out through that nozzle. Half rho V1 square plus rho GH1 is equal to P2 plus half rho V2 square plus rho GH2. I'm not doing anything new here. I'm just writing the Bernoullis principle, whatever we have derived in yesterday's class. कोई भी doubts नहीं है ना? ठीक है. What is P1? Pressure at the atmosphere. What is P2? P atmosphere. So P1 and P2 can I cancel off? Can I cancel off? बिल्कुल है ना? So cancel किया. Now rho GH2 on the right hand side of the equation, I'm going to take it to the left hand side. So how much of the equation is going to be? Rho G H1 minus H2 is equal to, right, half rho V2 square minus V1 square in the bracket. देख ले, half rho V1 square on left hand side of the equation, I'm going to take it to the right hand side. Taking rho by 2 as common, we have made the formula. Okay, now substitution, done. It is done. Rho G H1 minus H2. H1 is the total height, this is H2. So what is H1 minus H2? ये H है ना? H1 minus H2 is H. So I'm going to write that same. Rho GH half rho V2 square. We don't want V1, है ना? We are going to make a substitution for V1. Can anyone tell me how can we make the substitution for V1? I'm going to look into the chat box. आप ही बता दीजिए. Tell me, how can I make a substitution for V1, बच्चा लोग? Anyone? Whoever have learned this particular chapter in an amazing way will be giving me the answer, just like that. Go for it. Tell me, how can I make a substitution for V1? Anyone in the classroom? No. So, how many of you do remember this formula? A1 V1 is equal to A2 V2. Do you remember? A1 V1 is equal to A2 V2. Do you remember? You have to, because this is the equation of continuity. So V1 is equal to A2 by A1 into V2. Equation of continuity, very good. So V1 square, dekh le, here we have V1 square. So V1 square will be equal to A2 by A1 V2 the whole square. So A2 by A1 the whole square into V2 square. Fine. Okay, now nothing is left. You just need to rearrange and do it. Rho cancel. This 2 will go up. So 2GH the whole divided by 1 minus A2 by A1 the whole square is equal to V2 square. I took V2 outside as common. 1 minus A2 by A1 the whole square, that is left. This is the equation of V2 square. This is the equation of V2 square. So now I just need to write the equation for V2. So how much will be the equation for V2? I'm going to write here, right? V2 will be equal to root of 2GH divided by root of 1 minus A2 by A1 the whole square. Okay? Yes? Fine? Okay. So this is the equation to find out velocity to its maximum clarity. Okay, with its full value, right? If it's without any error, if you want to get the value, this is a formula. But we do always make approximation, है ना? देख ले, A2 by A1 का value देख ले. A2 is a very small area compared to A1. A1 is a very big area, isn't it? So A2 by A1, we approximate it as 0 almost. A2 by A1, A2 is a very small area. So we approximate it as 0. So 1 minus 0 square is 1. So root 1 is 1. So we do approximate this as root 2GH as the velocity of the efflux. The velocity with which the water comes out through the holes we just have derived right now. Clear? Muhammad Yusuf wa alaikum assalam. Now tell me, is it clear? Bacha log, with the smile on your faces. Yes? Everyone, please don't spam in the classroom. Yusuf Siddiqui, okay? Kindly, we all are learning here, isn't it? So awesome. So understood, Miara. Very good. Thank you so much for that. Shreya, clear. Kamlesh, Anthony, Shraddha, Miara, Crystal, with a smile. Very good, very good, very good. Okay, now tell me, how many of you are ready with a, okay, question here we have, a small question. Go for this question, mera bachcha log. Go for this question and give me the answer in the chat box. Jaldi se. Jaldi se. I'll just go down. Okay, I'll just bend down so that you all can see the options. Nothing, you don't have to do anything, just do the multiplication and put the values in the equation we just have derived, and that's it. Okay, so Preeti with option C, Jyoti with option C, then okay, so everyone option C, right? Shreya, C, Sabra, Jyoti. Shreya is going with option C. Very good, very good, very good. Hi PW learner, don't spam. Thank you. Okay, so yes, it is option C. Question is, what is the velocity of efflux? Formula, root of 2GH. Root of 2 into G is 10 into. Dekh le. A tank has an orifice, 3 orifice matlab that efflux, that small hole you make, at a depth of 3.5 meter, right? So the value of H is 3.5. How much you will get? Almost, if you take the root, 8.3 meter per second mil jayega aap logo. Not a big deal. Okay, fine. 8.3, very simple. Now we have one more Chotusa concept. Everybody open your textbook, right? Can you all see one more property of Bernoullis principle? Tell me which one it is. Tell me which one it is. One more property related to the applications. One more application related to Bernoullis principle is there. Tell me. Which one? You just can see on your screen right now. Yes, dynamic lift. So if you look into under the heading of dynamic lift, you'll see lot many examples are given, right? All these examples are based on the same principle of Bernoulli's principle. So I'll be explaining one among them. Okay, I'll be explaining one among the examples of dynamic lift. Others you all can read it because it is by using the same concept everything is being explained. Okay, ball moving without spin, everything. So here we are mainly going to discuss about how the aeroplane is lift up. Isn't it such an interesting topic, right? Such a big thing, right? Such a big procedure within some small concepts of Bernoulli's. We are going to explain how this flight is able to lift up. Shall we? Okay. Like, everybody either have seen in real or in movies or in YouTube or anything, right? The lifting of an aeroplane. है ना? देख ले. Is it directly going to lift up just like an helicopter? No, right? What will it be doing? What will be happening with this aeroplane? So first, this aeroplane will be making a horizontal movement along the road, right? It will be moving along the surface of the earth, making an horizontal motion like this. After making some motion, you will see that this aeroplane is being lifted up. This is what happens, right? So how this horizontal motion is making the aeroplane to lift up? Is someone giving a force in the upward direction to lift up some external force? No, right? This is simply because of the pressure difference. Let me explain, right? Okay. Now you will be asking me which part of the aeroplane is actually making it to lift up? Nothing but our wings. Just like the birds have the wings, the aeroplane also has a wings. Everybody have seen this, right? These are the wings. The special structure with which these wings are made, based on that or because of that, you can say that this particular aeroplane is lifted up. Just have a look at the wings of the aeroplane. If you look here and if you look at the cross section, it will be having a shape like this. Can you see that? You all can see a particular shape like this. Okay, a particular shape will be there, right, for this particular wings. Okay, now when this wings are moving in the forward direction, let's say that the wings are moving in the forward direction, everyone. In this direction the wings are moving with some velocity in the forward direction. In which direction the air will be flowing? The air will be flowing in this direction, hai na? Air will be flowing in this direction. Now the structure of this particular wings is being made like this. We already have discussed. So because of the structure, right, all the air which is moving on top of the wings will be moving like this ऐसे. Okay, it will be making a motion like this. I'll draw with a red color. Can you all see that? It will be making a motion like this ऐसे. It will be moving ऐसे. But whatever is the air which is moving below the surface of these wings will be moving by covering a larger area. On the top surface, air will only be able to flow through a lesser area, but the air which is flowing beneath the wings of the aeroplane will be passing through a large area. Matlab here area less and here area is more for the air to flow. Tell me, if area is more, what will happen to the velocity? Tell me, if area is more, what will happen to the velocity? I'll be asking to all the bacha logs here in the classroom. Tell me, bacha log, if the area is more, now what will happen to the velocity of the fluid flow? We all have learned equation of continuity. Area into velocity is a constant. Anyone? Wherever the area is higher, the velocity has to be lesser so that area into velocity can be a constant. Wherever area is more, velocity will be lesser. So here at the bottom surface, velocity will be lesser. What will be lesser? Velocity. When velocity is 2, tell me what happens to pressure. How can we understand the relationship between velocity and pressure? देख ले, Bernoullis Principle, P plus half rho V square plus rho GH is a constant, isn't it? Yes or no? Yes. At the bottom surface, velocity is chotu, lesser. Velocity is lesser. So in order to make the right hand terms a constant, what should be the pressure value? Pressure has to be larger so that the summation of all these things can remain as a constant. So at the bottom, wherever the velocity is lesser, the pressure will be higher. Pressure higher at the bottom surface. So because of the higher pressure at the bottom surface of the wings, there will be an upward force on the aeroplane, which is making the aeroplane to move up. So higher pressure, you know that always the push is from higher pressure to lower pressure. Yes or no? Yes or no? Yes. So wherever the pressure is higher, from there the push will be towards a lower pressure. So with that push, that aeroplane will be lifted up. समझ में आ गया? Understood? It is with the same concept. Remaining examples are also explained in the case of dynamic lift. You can just go through it. This is how the lifting of an aeroplane works. Shraddha, Sabra, Myara, Shreya, everyone with a beautiful smile. I can't see the smile from any one of you. I can't see the smile. समझ में आ गया सर विद अ स्माइल? बढ़िया बात है, बिल्कुल बढ़िया बात है. लेट तो नहीं हुई ना? थोड़ा लेट हो गया ना, आधा घंटा लेट हो गया. ओके श्रद्धा, श्रेया, अर्पण, everyone, amazing, very good. I can see that beautiful smile on the faces of all my bacha logs here. Okay, moving on. Now, ready to learn a new topic? आप ही बता दीजिए. Ready to learn a very new topic here in the class. Mayank, Mahi, Sema, Surya. Okay. Yes, let's do a problem. Okay, after this viscosity, so many problems are waiting for us, Arpan. Don't worry. Right? Okay, dynamic lift was actually a conceptual part. So, okay. So Myara is asking, sir, did you skip a blood flow and heart attack? No, you just go through it, right? Because based on the same concept, all those things are being explained. You just read it, you will be understanding it easily. I have told you at the beginning while I was started to explain. Okay. Now, viscosity. Viscosity क्या होता है? Read the definition first. Let's all read the definition. Okay, then I'll be making a better explanation. Everyone, along with me. बच्चा लोग, क्या है ये viscosity? Viscosity is the resistance of a fluid to the change in shape or movement of neighboring portions relative to another. Only 30% is clear, right? Only 30% is clear. It's very simple actually. In solids, we have learned about friction. When one body tries to move over the other, there exists a resistive force between the solids. We call it as what? Frictional force. Similarly, in the case of fluids also, when one layer of fluid is moving over the other layer of fluid, there exists a resistive force between them. Okay, that resistive force, we simply call it as viscous force. We simply call it as viscous force. And this phenomenon of having this resistive force between the layers, we call it as viscosity. Or kuch nahi. So it is simply a resistive force. Okay. Now, let us draw the figure and make the understanding of viscous force 100%. Okay. Dekh le. Here we have the ground. Okay. This is the surface of the ground, as you all can see. On the surface of the ground, liquid are flowing. Do you all remember when we were learning about streamline flow, how the liquids flow? Bacha log, you only tell me how the liquids flow. Liquid flows in layers, one layer over the other, isn't it? Liquid flow as layers. Layer 1, let's say, layer 2, let's say, layer 3, let's say, ऐसे the liquid will be flowing in layers over layers. Fine. Okay. Now, just look at the first layer. Every bacha log. Just look at the first layer. It is trying to move towards right with some velocity. But this layer is moving over a stationary surface, a surface which is not moving. So what happens when a liquid tries to move over a stationary surface? There it will be experiencing a resistive force. Yes or no? This first layer will be experiencing a resistive force. And that resistive force experienced, we call it as viscous force. FV, we call it as viscous force. And this viscous force experienced by the first layer will be so large. Why this viscous force experienced by the first layer has to be large? Because this viscous force is given to the liquid layer by this stationary surface. This surface, it's not moving. It is given by this particular stationary surface. This is the reason the viscous force experienced by the first layer will be so large. Okay. Now, going for the second layer. Isn't the second layer moving over the first one? Yes. So when it moves, won't it be experiencing a resistive force? Second layer? Yes. Let's call this viscous force as Fv dash. Tell me, is this viscous force, the viscous force experienced by second layer of liquid, is it going to be a larger one or a smaller one? Compared to the first viscous force, it's going to be smaller one compared to the first. Why the viscous force experienced or why the resistive force experienced by the second layer has to be smaller here in this case? Any idea? Very simple. Because the viscous force is given to the second layer by the first layer, which is already in motion. Okay, so the dragging force between the layer 1 and 2 will be less, so the resistive force will also be less. But in the case of the first layer was actually moving over a stationary surface, a surface which is not at all moving. So there the dragging force will be so much, so the resistive force will be very much higher on the first surface. So wherever the surface is having large viscous force, less velocity. So as we move up, the viscous force decreases, the velocity with which it moves will be larger. Velocity increases as we move up. And what about viscous force? Viscous force decreases as we move up. Understood the reason, I suppose. Okay, so if the liquid is flowing over a stationary surface, you will see the layers of liquid flowing as if. First one, lesser velocity. The layer on top of it, a bit more larger velocity. The layer on top of it, a bit more larger velocity, because viscous force keeps on decreasing, so the velocity keeps on increasing. Fine? Okay. So this force existing between the layers of the liquid, we call it as viscous force. Clear hai na sabko? With a smile ke saath. With a beautiful smile. Yes. Okay. And what do you call this phenomenon as? Ye phenomenon ka naam kya hai? This phenomenon, the property of the liquid to have this viscous force, that is called as viscosity. Ye property ka naam hai viscosity. Okay. And what do you call this liquids? Those liquids which has or which shows viscosity, we call those liquids as viscous liquids. Okay, we call these kind of liquids where there exists viscous force, viscous liquids. The force exists in between them, viscous force, and the phenomenon, viscosity. That's it. Okay, yes. Next. Now we are going to write the exact formula to find out the viscous force acting between two layers of liquid. Shall we do that? Shall we do that? Arpan, Miara, Shraddha. Shall we do that? Because after this questions are gonna pop up. So I want every one of you to give me the questions. Sorry, answers to the questions. Okay? Gomesh, dekh le mere bachcha log. Everyone listen to me here. Right? So let's say these are the two layers of liquid, which is one is moving over the other. Right? If the distance between three layers of liquid, if we are marking it as dy, and if the change in velocity, matlab the velocity difference between the layers of the liquid is du. What is du? Right, change in velocity. change in velocity between the two liquid layers is du. And if the area of contact is A, if the area of contact is A, mera bacha log, the viscous force acting between them is found to be directly proportional to the area between contact between two layers. Du directly proportional to the change of velocity. Matlab, if two layers are having a huge change in velocity, the viscous force will be larger. I'll give you an explanation. Dekh le, in the first case, the upper layer is having a velocity of 25, lower is having a velocity of 20. What is change in velocity? 5. Now another case, here the upper is having 30, the lower is having 10. What is change in velocity? 30 minus 10, that is 20. Tell me, in the case 1 or in the case 2, we can have the experience of larger viscous force. Where can we have a larger viscous force experienced? बता दे बच्चा लोग, बता दे मेरा बच्चा लोग, where can we have a larger viscous force experienced? Where we have a larger viscous force experienced, wherever there is a large change in velocity, 30 minus 10, है ना? There we have a large change in velocity. There we can have a larger viscous force experience in the second case. If you want more example of this viscous force, and I'll just tell you. Just put your hand inside the water, right? Okay, and try to move it. Okay, you are initially moving it slowly, and again after some time you are moving it very fast. Where you can experience a larger force? When you move the hand so faster, है ना? Isn't it? So wherever the velocity of motion is larger, the viscous force will also be larger in that case. ठीक है? Divided by dy. So F is directly proportional to A du by dy, and converting this into an equation, this is equal to, how will you convert a proportionality into an equation, bachcha lo? By multiplying it with a constant, and that constant we call it as, constant ka naam anyone? Constant का नाम coefficient of viscosity. इसका नाम है coefficient of viscosity into A du by dy. So the viscous force between two layers of liquid is eta A du by dy, where eta is the coefficient of viscosity. It is called as coefficient of viscosity. Fine? Very good, very good. Now, tell me, what does this constant represents? It represents how viscous the given fluid is, right? Those liquid which is having high viscosity will be having a high coefficient of viscosity value. Those liquid which are less viscous, that will be having less coefficient of viscosity value. So it basically represents how viscous the given fluid is. Okay? And it only depends upon the liquid, okay, and the temperature. So the coefficient of viscosity depends on only two things, the liquid, okay, and obviously on the temperature. Matlab, even if we change the temperature, coefficient of viscosity will change. Can anybody make a guess, bacha log? I'll just ask you a question, okay? If we increase the temperature, what will happen to coefficient of viscosity? You only tell me. If we increase the temperature, jaldi say everyone. Everyone, if we increase the coefficient of viscosity value, matlab, if we increase the temperature, what will happen to coefficient of viscosity? Coefficient of viscosity will reduce. Less. Why? If we increase the temperature, molecules will start moving faster, isn't it? So that resistive force will be lesser. So if the resistive force becomes lesser, coefficient of viscosity obviously will be lesser. So I'll just write it, okay? If temperature is increased, coefficient of viscosity value will reduce. Very good. ठीक है ना? Okay. That was a very good statement, Sabra. I love myself. Wow. Okay. Okay, moving on. Moving on. Everyone, no doubt still here? Right, okay. Now, you all can ask me, sir, what is the unit of this coefficient of viscosity? Unit? The SI unit of coefficient of viscosity is Poiseuille. Poiseuille we sell it. Poiseuille. Okay, this is the SI unit. And there is CGS unit also, bachalo. Unit kitna hai? Poise. So SI unit is Poiseuille. Okay, and the CGS unit is Poise. And the conversion is 1 Poiseuille is equal to 10 Poise. So by heart this, ये बहुत important है. ये बहुत important है मेरे बच्चा लोग. The unit of coefficient of viscosity बहुत important है. Write it down. Okay. So इधर तक complete हो गया तो question के लिए you all should be ready. Question के लिए ready मेरे बच्चा लोग. जल्दी से note कर ले and tell me, are you all ready for the questions? Array, Harpan, not this time. When we discuss about capillarity, we'll be going with all these concepts, okay? Okay, got it? So here we have the question. This is a very good question. I want every one of you to give me the answer. Waiting for the answers from every one of you. Questions are right in front of you. Ujjwal, Vomesh, Arpan. Vomesh, mood sad hai. Arpan already gave me the answer. It's option B is what Arpan has gave others. Others answers. Okay, just like Miara. Miara like her all times. Maybe C or D options. My duty to pick the answer, hai na? Mayank. Okay, so you all can individually block the person of Mayank, hai na? I did it from my end, so you all can do that. Just click on the name and click on block. Done, 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 done. Yes, D option is correct, hai na? Very good, very good. So Kamlesh, Shraddha, very good. Let's do this question. A plate, okay, of area 2 meters square is made to move horizontally with a speed of 2 meters per second, okay, by applying a horizontal tangential force over the free surface of a liquid, okay. If the depth of the liquid is 1 meter and the liquid in contact with the bed is stationary, coefficient of viscosity of the liquid is 0.01 poise, find the tangential force needed to move the plate. It's a very good question. Take it. This is the stationary surface, okay, and we have a layer of liquid which is at a height of 1 meter, right? And to this layer of liquid, what is there? Onto the topmost layer of the liquid, what we have? A plate is there. Okay, a plate of area 2 meters square is there. We are going to make this particular plate to move with a velocity of 2 meters per second. So when you have to move this plate, the layer of liquid which is in contact with this plate should also be made to move with a velocity of 2 meters per second, hai na? Plate will move, the liquid layer in contact with the plate move with 2 meters per second. ठीक है. When it moves, tell me what happens. Tell me what happens when a layer of liquid moves. Viscous force, won't it happen or not? Yes, there will be happening a viscous force on this particular layer of liquid. Now, if you want to make this particular layer of the liquid and the plate to move with a constant velocity of 2 meters per second, what is the condition? You have to apply an equal amount of opposite force, that means a force towards right, so that the net force acting on the body can be 0 and this plate can move with a velocity of 2 meter per second. है ना? So you have to apply a force towards right so that you can cancel the viscous force acting on the body. So the amount of force that you have to apply is equal to viscous force. Just write down the heading, just write down the formula for viscous force. Answer is done. Formula eta A du divided by dy. What is eta? 0.01 poise. But we know that it has to be converted to Poiseuille. What was the conversion rate, bacha log? 1 Poiseuille is 10 poise. Okay, so 0.01 poise is equal to how much Poiseuille? 0.001 Poiseuille. Fine, no doubts, I suppose. Multiplied by area. Area kitna? Directly given as 2. Du. Change in velocity between the layers. So this is one layer, this is the bottommost stationary. This is of velocity 0, this is of velocity 2. So what is the change in velocity? 2 minus 0, 2 divided by dy. That is the width between these two layers. How much is given? 1 meter. वो भी substitute कर लो. So how much this is? 2 into 2, that is 4 into 10 power minus 3 Newton, which is option D. मिल गया तो मिल गया, आंसर भी मिल गया, मजा भी आ गया. What do you all say? What do you all say, मेरा बच्चा लोग? Is the concept clear? Is the concept clear? Done, done, done. Yes. Arpan, Ujjwal. आ गया तो आ गया. Noted. Yes, with a smile. Okay, amazing. Okay, oh मैं श्रद्धा म्यारा super duper clear. बहुत बढ़िया बात है. Okay. Now Stokes law heading. Stokes law. It is from here. You can expect many questions, मेरा बच्चा लोग. Many questions you can expect from this particular topic, and questions are also waiting for you. Okay, related to the concept of Stokes law. Shall we? Everybody, write the heading Stokes law, and first let us see ये Stokes law क्या होता है मेरा बच्चा लोग, है ना? क्या है ये Stokes law? Now, in concept of viscous force, what we were discussing? We were discussing the viscous force or the resistive force acting between two layers of liquid, है ना? My question, will there be a resistive force, right? Will there be a frictional force between layers of liquid and layers of solid? Yes. And it is based on this, we have this Stokes law. देख ले. Let's say that these are layers of air, okay? मतलब a fluid, है ना? So these are the layers of air. So here we have the layers of air, just like that. So in this particular region, I'm going to hold a ball, okay, or any spherical object. Okay, so here we have a spherical object, a spherical ball is here. I'm going to drop it. Tell me what happens. This ball will start coming down. When it comes down, you can see that the surface of this ball is actually dragging, isn't it? It is actually dragging the layers of fluid. Can you see that? Yes. Okay, the surface of the solid is actually dragging the layers of the liquid. So when there is a dragging, what happens? Yes, won't there be a force? Yes. So there exists a force between the surface of the solid and liquid when solid try to move through a fluid or a liquid. This force is given by the formula in Stokes law, and it is being explained that if a spherical object is made to move with some velocity of v through a fluid, the force acting on this, the dragging viscous force acting on this is given by the formula of 6 pi eta coefficient of viscosity or radius of this spherical object into velocity with which it moves. So this is the viscous drag force experienced by a solid object when it moves through a fluid. Very, very important questions can come just like that. So Write it down, and this is a formula. No much explanation is required, and no much more understanding is also required for this. No derivations are there, so we don't need any derivation, just by heart this formula. ठीक है, ये understood what is this है ना? When a solid is moving through a fluid, it will be experiencing a resistive force. That force we call it as dragging viscous force, right? We call it as drag viscous force or dragging viscous force, okay, with the formula of 6 pi eta RV. Okay, now look into this equation. Note किया ना सब बच्चा ने, म्यारा, प्रीति, माही, श्रद्धा, सब ने नोट किया है ना? ठीक है ठीक है ठीक है, ये देख ले. Now in the equation of this force, it has velocity. मतलब larger the velocity with which it moves, larger is the force it experiences. समझ में आ गया? Larger the velocity with which it moves, larger is the force it experiences. I have given you one example, है ना? Like to move your hand inside water. If you move it slowly, the force you experience is lesser, isn't it? And once you try to move your hand so faster, the viscous force or the dragging viscous force experienced by your hand because of the liquid layers will be larger. Understood? Why there is a velocity in the equation of force and why the velocity is directly proportional to force. Okay, समझ में आ गया? So this is the dragging viscous force and it is directly proportional to velocity. Okay, good. Now we are slowly going into the concept of terminal velocity, but I'll make you only to explain and understand how this concept of terminal velocity is. Just read this question and try to give me an answer for this. Just read this statement and this question, give me the answer. Arpan, proof is not required. Okay, there is no need of proof. It is not given in either in your NCERT. So क्यों चाहिए आप लोगों को? Okay, it's a very big proof which is not up to the level of 11th and 12th standard, so we don't need. Remembering concept can only be done once you start doing as many problems as possible. जितना problem कर सकता है ना, as many problems you can solve, try to solve it. You'll be more and more good in this. Arpan is giving the option A, I can see. Kamlesh is giving the option B. Then Myara is going for the option B. Kamlesh with B. Explain. I'm going to explain this. Don't worry. Welcome to the class, Patakya. Okay. Anthony, option B. Very good. I'll just tell you. देख ले. A body is freely falling in a viscous liquid. When it falls, what happens? It can be experiencing what? It will be experiencing a dragging viscous force with the formula of 6 pi eta RV. So, question is finally, what will happen to that particular body which is falling freely through a viscous liquid? Finally, after some time, what will happen? The answer is, it will be falling with a constant velocity. And that constant velocity is called as terminal velocity. Don't think about it, I'll explain. Okay. The answer for this is it falls with a constant velocity. So start asking why. देख ले. Everyone listen to me here. This is our spherical object. Obviously it will be having some mass. Because of mass, won't there be a force acting? Downward its weight mg, that is 10. This is kept in a fluid. If a body is kept in a fluid, other than its weight, forces, which is the other force? मेरा बच्चा लोग? There is a buoyant force acting on the body. भूल गया? When you have a body inside a fluid, there will be an upward force. We call it as buoyant force. Right? Let me give some numerical value to it. Let's say it is 3. So that I can help you understand this. Buoyant force is 3 actually. Fine? Okay. So initially we were holding it, matlab it was initial velocity is 0. When initial velocity is 0, will there be a Stokes formula, dragging viscous force acting, which is by the formula of 6 pi eta RV? Will there be a dragging force acting on it if we are initially holding that body of mass m? No, nothing will be there. Right, dragging viscous force of 6 pi eta RV will not be there because initial velocity is 0. So tell me, what can we comment about the motion of the body? There is a force of 10 downwards and 3 upwards. So 10 minus 3, 7. So with a net downward force, the mass will be moving down. So the body starts moving. The body will start attaining some velocity. So once it attains some velocity, what will happen? Then it will start to have some viscous force upward. Let me say that it started to have a viscous force of, let us give some random value. Okay, it became 4. Once it started to move, there happens a viscous force of 4. Now look into the force and tell me. 10 downwards, 3 upwards, 4 upwards. Net force in this case, 10 minus 7, that is 3 Newton. Still, the body will start be moving with a downward acceleration. है ना? ठीक है. So acceleration, velocity again increased. Okay, so this viscous force again increased. Let me say that it became 7. What happened? The above viscous force is now 7. Tell me what's the net force now? Tell me what is the net force now acting on the body? What is the net force acting on the body? It is 0 because downward force and upward force became equal. What is the acceleration of the body right now? It becomes 0. And once the acceleration is 0, after that what will happen to velocity? Velocity becomes constant. So what happened from the initially velocity was 0. Velocity increased and reached a maximum value of velocity. And after that, the body will be moving with a constant velocity, isn't it? So this maximum velocity with which the particle moves, we call it as, this maximum velocity with which the particle moves, iska naam hai terminal velocity. What do we call it? We call it as terminal velocity. Understood the concept of this terminal velocity? Initially a body with 0 velocity increases its velocity, reaches a maximum, and thereafter it will be moving with a constant value of velocity. So that maximum value of velocity we call it as terminal velocity. Clear? Everyone shout out in the classroom and tell that. Is the concept of terminal velocity clear? Everyone, yo. Shout out everyone. Got it, Shreya, Myara, Shraddha, Preeti. Awesome. Yes. Sir, if someone gets 138, is it really bad? Depends upon how tough the paper was. Right? Depends on so many things. Okay, so arg is high, the energy is high, everything is super high. Let's proceed further in finding out the equation for terminal velocity. Shall we do that? Okay, the very last concept. Shall we find out an equation for terminal velocity? Yes. Now, tell me, when can we have the value of terminal velocity? When the net force acting on the body is equal to 0. When the net force acting on the body is equal to 0, the body moves with a constant velocity. That value is called as terminal velocity. So, at the moment what we can say, net force is 0. So, the net upward force will be equal to the net downward force. Which are the upward forces acting? Buoyant force plus viscous force is equal to the downward force, which is mg. Formula for buoyant force, volume of the body, density of the liquid into g, plus viscous force formula 6 pi eta rv. Mass, how will you write? Volume of the body, density of the body into g. Mass of the body is volume of the body into density of the body. Buoyant force is volume of the body into density of the liquid. Small change there. Okay. Now 6 pi eta r velocity. Now taking this v rho g to the right hand side and taking volume and g as common. Volume and g as common inside the bracket, sigma minus rho. कोई doubts? कोई doubts मेरा बच्चा लोग? कुछ भी नहीं है ना? How will you write volume of a spherical object with a radius of r? 4 by 3 pi r cube. Volume, isn't it? Into density, volume is, okay, so volume, isn't it? Into G into sigma minus rho. What is here on the left hand side? 6 pi eta rv. Now we can cancel out what all is possible. So jaldi cancel kar le, pi, pi, ho gaya. Then 1r, this r cube square ho gaya. So this 6 and 4 will be cancelled, and the final equation for velocity, I'm going to write it, final equation, that is equal to 2 by 9 r square g sigma minus rho. Clear? This is the final formula for terminal velocity. 2 by 9 r square g sigma minus rho. If you got it, that is the equation for terminal velocity. Done, done, done. और कुछ नहीं है, और कुछ नहीं है, और कुछ भी नहीं है करने के लिए. Okay, absolutely fine. I hope you all know r is the radius of the spherical object, g acceleration due to gravity, sigma the density of the material, rho density of the fluid. Why you didn't update me one thing? देख ले मेरे बच्चे लोग, this eta comes down, this eta was there on the denominator. अरे क्यों नहीं update करता है? Why you don't remind me when I miss some terms? Why you don't update me? अरे बच्चे लोग. So you have to be super cautious, super alert here in the classroom, है ना? That eta है ना, on the left hand side of the equation, when it goes to the right, that will be going down as the denominator. So 2 by 9 r square g sigma minus rho by eta. Okay. Okay, very good. Shall we do a question and we'll wind up the session? Okay, we'll do a question from this, then we'll be winding up the session. Tomorrow we can start with surface tension. Okay, देख ले. Do this question. Very simple, छोटू सा question है. ये कर ले. It's a very beautiful question. Okay, so not much to do. Basically on the formula we have learned. Waiting for the answers from all my dear super beautiful bacha logs here. Go for it and just tell me the answer just like that. 12th ka class will be starting after the exams. है ना? Now exams are going on. So we'll start after the exams. Shreyansh, tomorrow war between me and Max. Arre wah. Try to win the war, okay, Shreyansh? Miara is like, is it C? Others? Shraddha is also going for the option C. Everyone? Okay. Now, let us discuss. It's very simple, it's not a big deal. Two spherical raindrops of equal size are falling vertically through air with a terminal velocity of 1 meter per second. Okay. Question ye ki, what would be the terminal speed if these two drops is combined to form one large spherical drop? Okay. Once you combine these two drops and make it one single drop, how much is the terminal speed in that case? Okay. We'll go step by step. Two drops we have. Both are having the equal radius r. What will be the formula for terminal velocity in this case? That is equal to 2 by 9 r square g, ठीक है, sigma minus rho divided by eta. Isn't this? Now, this value of terminal velocity is given as 1 meter per second. I'm going to substitute this. 1 is equal to 2 by 9 r square g sigma minus rho divided by eta. ठीक है? बस. Now, you are going to you are going to combine these two and going to make a bigger drop of some radius r dash. So obviously, if you want to get the value of terminal velocity in the second case, you must be substituting r dash in terms of r. Any idea for that? To substitute r dash and r? Array, this volume V1 plus this volume V2 will be giving the volume of the bigger one, because you combine the two drops to get the bigger one. So volume V1 plus volume V2, you get the bigger volume. Both are having the same volume, hai na? So I'm going to write 2 times 4 by 3 pi r cube. 4 by 3 pi r cube is the volume of one single drop. If you add both of them, 2 times is equal to volume of the bigger one. How will you write volume of the bigger drop? 4 by 3 pi r dash the whole cube. 4 by 3 pi cancel kar le, taking the cube root on either sides. R dash is equal to r 2 raised to 1 by 3. So the radius of the bigger drop r dash is equal to 2 raised to 1 by 3 into r. Now done. Now kuch nahi hai, you just need to substitute for terminal velocity and substitute for r dash, you will get the answer. We can write. So terminal velocity in the second case, formula 2 by 9, here the radius is r dash the whole square into g, then sigma minus rho divided by eta. Shall I substitute for r dash? R dash is equal to 2 raised to 1 by 3 r. We already got the answer. We already made the substitution. Substitute kar le. 2 by 9, 2 raised to 1 by 3 r the whole square g, sigma minus rho divided by eta. 2 raised to 1 by 3 the whole square, 2 raised to 2 by 3. What is remaining? 2 by 9 r square g sigma minus rho divided by eta. हो गया. 2 raised to 2 by 3. इसका value कितना? How much is the value of that part? How much is the value? How much from here? That is having the value of 1. Everyone, open your eyes and just look at it. Isn't it having the value of 1? Yes. So just substitute 2 by 3 into 1 meter per second. That's our answer, which is option A. मिल गया सबको? Everybody got it? Yes, everyone, every bacha logs here in the class. All awesome, all good. Right? Okay. So tell me, surface tension, surface energy concept will be tomorrow discussing in tomorrow's class. So tell me, how was the session? Cancellation is the best part I like. Okay. So for doing the cancellation, you will have to reach to the final equation. Okay. Make sure that you reach till there. Okay. So everyone. So next chapter we'll be taking thermal properties of matter. From next Monday onwards, we'll be starting our new chapter. So loved it, Anthony. Miara, amazing. Thank you. Shreya, nice. Preeti, amazing. Enjoyed. Okay, very good, mera bacha log. So I think you all have enjoyed the class here, right? So those who want personal guidance, and if you want to have personal mentoring, and if you want to solve your doubts in the classroom for all your specific doubts, you all know where you all have to be. You all have to be here in this batch, which already has started for the term 2 students of class 11. We call it as Spark 2. You all can see along with me that amazing teachers here we have, isn't it? So Shalini ma'am with 5 years of experience, right, for biology, chemistry, is Abha ma'am with 24 plus years. Then Anita ma'am is having 18 plus, 32 plus years for mathematics. Deepak sir. So what else you need? So jaldi se jaldi join kar le for this, and you all know, for getting 10% of discount, the code for joining is AMB10. Fine? Okay, good, awesome. Then these are the other batches. As you all can see, expedition batch for term 2 exams, CBSE class 11, as you can see. then a Spark 4 term 2 science. So now I just want to tell you, bacha log, the offer is going on for the first 1,000 subscribers along with 12 months of subscription, extra 6 months free is given, so don't forget about it. And if you want extra 10% of discount, the code is AMB10. Now special class, I really forgot to mention, bacha logs, there is a special class happening on this Wednesday and also on Friday, both on the topic of both on the topic of fluids. So here we'll be having the MCQ practice as a pole war. Okay, on Friday we'll be mainly talking about we'll be having NCERT problem, NCERT exercises. Okay, NCERT exercises and examiner questions will be there. So jaldi se jaldi join kar le everyone. Those who don't know how to join for special classes, first let me tell you, this is completely free classes. It's completely free, happening in an Unacademy platform. What you all have to do if you want to be a part of the special class, download the app, download the Unacademy learning app, then log in, go to menu, click on specials. Okay, after clicking on specials, just type in the code of AMB10, you will be getting all these classes, right? Fine. Okay. Song tomorrow, I don't have my guitar. I just came to Bangalore today, so I just need 1 or 2 days to settle down. So then everything I'll arrange it. Fine. So bacha log, those who haven't liked the session, jaldi se like kar le, kisko wait kar hai? So show some love towards your Ameer sir, right? So jaldi se like and share the class with all your friends, mera bacha log, everyone, and subscribe to the channel so that you will get all the notifications on time. Okay, so thank you so much, Shreya, Preeti, Miara, BTS Army. Okay, so everyone, bye bye. Thank you so much. We'll be meeting you in the next class. Till then, take care. Bye bye.